All right, good morning or good afternoon. Today we are moving into a new topic where we're going to be learning about something called bivariate data and frequency tables. By the end of this lesson, you'll be able to organize bivariate data, categorical data, into a two-way table. We call this a two-way frequency table. You'll know you're successful when you can calculate row and column relative frequencies and interpret them in context. We're going to go through some examples. We'll work a little bit together as a class, and then I'm going to let you guys work together as small groups before we get into our closure and then exit ticket and reflection. Please keep in mind our class expectations as we move throughout the lesson. Let's get started. All right, starting with example 1. It says, on an upcoming field day at school, the principal wants to provide ice cream during lunch. She offers 3 flavors, chocolate, strawberry, and vanilla. She selected your class to complete a survey to help her determine how much of each flavor to buy. Okay? So if you think about this, this is a pretty logical thing that a lot of people do. She's buying ice cream for the whole school. She wants to get an idea of how much she should buy. So she just surveys one class to see, okay, well, how much chocolate do they like? How much vanilla? How much strawberry? And then using that data, she'll buy the ice cream. Okay? Number 1 says, answer the following question and wait for your teacher to count how many students selected each flavor. Then record the class totals for each flavor in the table below. Which of the following 3 ice cream flavors is your favorite, chocolate, strawberry, or vanilla? So in this lesson, if we were in person together, we would do this actually together and find these numbers. But because we are not, we're just going to write some random numbers in here. So let's just write 5 for chocolate, 7 for strawberry, and 10 for vanilla. So imagine I sampled you guys and 5 of you told me you liked chocolate the most, 7 strawberry, and 10 vanilla. And then we want to always put our total at the end. So we have, 22? The total of 22 surveyed. Okay. So this is called a frequency table. It just kind of organizes the numbers that we have, the data that we collect. Okay. Looking at this table, we are going to interpret some things before we move into like the meat of our standard for today. It says, which ice cream flavor do most students prefer? Well, looking at this table, you can see that most of the students prefer the vanilla ice cream. Okay, which flavor do the fewest students prefer? Fewest students prefer chocolate in this case. And then it says, what percentages of students preferred each flavor? And we want to round to the nearest 10th of a percent. So this is something we did in 7th grade, is we were able to find percentages. So here's how you're going to find this percentage. You're going to set it up as a fraction. Okay? So you're going to have the number out of the total. So the frequency they give you divided by the total. So let's do chocolate first. Okay, so for chocolate, there were 5 students who selected that out of the total, which was 22. Okay? Now what we're going to do there is we're going to put this into our calculator. 5 over 22 is the same as 5 divided by 22, which is going to give us a decimal. And that decimal is 0.22. And I'm just going to round it off there. Okay? From there, we are going to turn this into a percent. All we have to do is times it by 100, which just means you're moving this decimal over twice. And this is 22%. Okay? So I don't know if you remember this from 7th grade, but we're going to do it a few times here. We're going to do it for strawberry and vanilla. So just make sure you have it down. All right, so strawberry. All right, for strawberry we had 7 out of 22 who chose this. So we're now going to turn it to a decimal. 7 divided by 22. We get 0.318. I'm going to round this to 0.32. And then from there, we're just going to multiply this by 100, which just means you're moving this decimal point twice to turn it into a percentage. This is 32%. Okay? And then the last one we're going to do is that vanilla. And for vanilla, it was 10 out of 22 students preferred vanilla. So we're going to be doing 10 divided by 22. 10 divided by 22, and my calculator is 0.4545. I'm going to round this to 0.45. From there, we are supposed to multiply by 100, which is the same as just moving this decimal point twice. 2 zero spaces. We're actually going to learn about that pretty soon. And this is about 45%. Okay? And those are the percentages for this table. So we're going to be doing this today as we move throughout our lesson and interpret some data here. Please make sure you have this down and let me know if you have any questions before we move to the next slide. We're going to continue to interpret this. All right. Number 5, it says, do the numbers in the table in exercise 1, I put it off to the side here for you as well, summarize the data in a categorical variable or a numerical variable. So it's asking basically, was this survey about a category of something or about a number of something? Well, what was the survey about? It was about ice cream flavors. Are ice cream flavors a category of something or a number? Well, ice cream flavors are a category, right? So this is categorical. Okay, because we are finding numbers for categories. Okay. Number 6, do the students in your class represent a random sample of all the students in your school? Why or why not? Discuss with your neighbor. We're not going to discuss with our neighbor, but the biggest or the most important word here is random sample. Was this sample random? No. There's no indication that she randomly pulled people throughout the school to sample them. Would that have maybe been a better sampling? I think so. If she sampled, 3 kindergartners and 4 second graders and 5 third graders, you know what I mean? Instead of just doing one specific class. Think about sampling a class. People overhear each other's answers. And they're the same age, so maybe that has something to do with it. So, no, this is not a random sample. She sampled the whole class, right? Number 7, is your class representative of all the other classes at your school? We just talked about this. No. And the reason being, your ages are different, your interests are different, etc. It is not representative of all the other classes. It might be closely represented to like your 7th grade peers or your other 8th grade homerooms, but it's not going to be representative of kindergarten. It's not going to be representative of 5th grade. Okay? And then number 8, it says, do you think the principal will get an accurate estimate of the proportion of students who prefer each ice cream flavor by only using your class? No. We just talked about this. She should sample people from many classes. Okay, if she's trying to estimate for the entire school, she should do a random sample from kids throughout the entire school. Now, does it make sense to ask every single student? No, but it should be a small subgroup, right? Maybe kids who are just walking in throughout the day, she just randomly asks, hey, what's your favorite flavor of ice cream? And marks down the tally mark. Okay? So let's go ahead and move on to the next example. After you have all this down, we're just kind of interpreting it at this point. Okay, to just build some background and vocabulary for you, I'm going to go through this slide. It's going to help us out a little bit. It says students in a different class were asked the same question about their favorite ice cream flavors. The table shows the ice cream flavors and the number of students who chose each flavor for this class. This table is called a one-way frequency table. Please highlight that, one-way frequency table. because it shows the counts of a univariate categorical variable. So a few things I want to show you here. Univariate basically means one variable. If you think of like unicycle, one wheel, univariate, one variable. Right? The only variable that's changing up here is the ice cream flavor. Okay? And our information was categorical because these were categories. It wasn't asking like the age of students. It was asking the age of student. That would be numerical because it's asking about a number. This is asking about a flavor. So those are the different categories there, okay? And then down below, it gives you the counts, right? You compute a relative frequency. So these are the frequencies, 11, 4, and 10. And we find a relative frequency by doing the count for each category divided by the total. That's what we did on that first slide, okay? So if we're doing this for chocolate right here, 11 out of 25 students answered chocolate. So the relative frequency, this fraction that we're going to make, is going to be 11 out of 25. And when we divide that, we get 0.44, which we know is the same as 44% if we just move that decimal point over. Okay? And we're going to continue to do this throughout the lesson. Just wanted to make sure you have a good little background before we move on. Let's continue. All right, so I want you guys to try this with me. It says, what is the relative frequency for the category strawberry here? So we're going to be looking at strawberry. And remember, we want our frequency divided by our total. So what was the frequency for strawberry? It was 4. And what's the total number of students surveyed here? 25. Okay, so please take a second to turn that into a decimal in your calculator. 4 divided by 25. Give you about 10 seconds. All right, you should have got that 4 divided by 25 is 0.16. And if we want to turn this relative frequency into a decimal, this is 16%. Okay? Or sorry, a percentage. I don't know why I said decimal. All right, number 10 says, write a sentence interpreting that relative frequency in the context. So what does this mean right here? What does 16% mean? Well, this is what it means. It means about 16% of the students surveyed prefer strawberry. Sometimes it's hard to interpret things, but these are pretty simple because literally we just look at that and we think, oh, what are we looking at? Strawberry? Oh, what does that mean? 16% like strawberry. Okay? Very simple little answer we write here. Go ahead and make sure you have that down, and we're going to move forward and answer a few more questions about this. All right, we're going to continue with the same kind of situation, just moving into a little bit more depth with it. It says the principal also wondered if boys and girls have different favorite ice cream flavors. She decided to redo the survey by taking a random sample of students from the school and recording both their favorite ice cream flavors and their genders. So she's recording two things now: favorite ice cream flavors and their genders. She's going to ask them two questions. Which of the following ice cream flavors is your favorite? And what's your gender, male or female? Okay. The results of the survey are as follows. So 30 students, out of the 30 students who prefer chocolate ice cream, 22 are males. So 30 students prefer ice cream, 22 are males. Well, that would mean that how many are females who like ice cream or chocolate ice cream? 8 females. Right? Because 8 plus 22 is 30. Okay, the next one. Of the 25 students who prefer strawberry, 15 are females. So that would mean that the rest are males. So then 10 would be males. Okay. And of the 27 students who prefer vanilla, 13 are males. So the rest are females. 27 minus 13 is going to be, what, 14? So 14 females. Okay, so just to reiterate some things, 22 males like chocolate, 8 females like chocolate. 15 females like strawberry, 10 males like strawberry. 13 males like vanilla, and 14 females like vanilla. Okay? The values of the two variables, which were ice cream flavor and gender, were recorded. Since both of the variables are categorical, the data is a bivariate categorical data set. So there's two variables, right? So we now call this bivariate. And we're still talking about two categories, so this is categorical. Okay? The next question says, can we display this in a one-way frequency table? Why or why not? We cannot display this in a one-way frequency table because we have two different frequencies, right? Males and females now. It's not just, oh, what's your favorite ice cream flavor? There's two questions. So no, because our data is bivariate. Okay, we have two variables, so we have to show both of those in our table. It can no longer be one way, it has to be two way. Okay, let's continue with this on the next page. All right, so on this page, we're actually just going to take that information and write it down in our table. So I'm going to start off and do one of these for you. It says, of the 30 students who prefer chocolate ice cream, 22 are males. So I'm going to do chocolate with you. So there are 30 students who prefer chocolate ice cream. Okay? So there's a total of 30. 22 of those are male. And so how many left are female? We already kind of talked about this in the last slide. That would mean 8 are female. Okay? I'll start this next one with you. Of the 25 students who prefer strawberry ice cream, so we're going to go to strawberry, 15 are females. So how many total students like strawberry? 25. How many of those are females? 15. So I want you to fill in how many are males. I'll give you about 10 seconds. All right, you should have decided that if there's a total of 25 students and 15 are female, then the rest are male, which means the rest is 10. You could just do 25 minus 15 and get that 10. Okay? Now I want you to please do this last row for vanilla on your own. I'll give you about 20 seconds to fill that in. All right, and you should have found that there were a total of 27 students who liked vanilla. 13 of those students were males, which means 14 were females. Okay, the last thing we want to do in this two-way frequency table is find our total over here. Okay, so there were a total of this many male students, 22 plus 10 plus 13. 22, 32, 42, 44, 45. 45. So we're just adding all of these numbers up. 22 plus 10 plus 13, total of 45 students for males. For females, we're going to do 8 plus 15 plus 14. So please find that total. I'll give you 10 seconds. All right, you should have got that there were 37 total female students. And then the last one that we want to fill in here is our total students overall. So if there's 45 male students, 45 female students, we're going to add these up and find out how many total students we have. So 45 plus 37, that gives me 82. And I just want to make sure it works on the other side as well. We do all of the students added up is 30 plus 25 plus 27, also 82. Yep, it is. So I know that my numbers all matched up and I did this correctly. There's a total of 82 students overall that we're serving. 45 were male, 37 were female. Okay. Now that we have our frequencies filled in, we now want to find our relative frequencies. So remember, relative frequencies are different than just frequencies. Relative frequencies are your percentages. Okay? So we're going to do this together and a little bit on your own. I'm going to start with the chocolate. So we had 22 male students who liked chocolate. So for chocolate, it's going to be there's 22 of them out of how many total students are there in this survey? 82, right? Okay. 22 divided by 82 in my calculator is 0.268. I'm going to round that to 0.27. And that is about 27% here. Okay? So about 27% of the people surveyed were males who liked chocolate ice cream. Okay? Let's do females who like chocolate ice cream. So this one number was 8 out of 82. Okay? 8 divided by 82 in my calculator is 0.09. And if I move this decimal over, this is about 9% or 10%. Okay? And then I'm going to do the total, so figure out how many people totally liked chocolate ice cream. There were 30. So 30 out of the 82 total kids surveyed liked chocolate ice cream. So I'm going to turn that into a decimal. 30 divided by 82 is 0.365. I'm going to round this to 0.37. About 37% overall liked chocolate. Okay? Let's do strawberry. Let's just write the fractions and maybe you can find the decimals. So the first one is 10 out of 82. The second one is 15 out of 82. The third one is 25 out of 82. All right? So I want you to find the decimals and then turn them into percents. And then for this last row, I want you to do it as well. We had 13 out of 82. 14 out of 82. And 27 out of 82. So please find those relative frequencies. And then the last row. All right, so please fill in these with the numbers that you calculate, and we'll go over it in about 2 minutes. All right, for this strawberry column, I went ahead and got the decimals for you. Now you just have to turn them into percentages. 0.12 is the same as 12%. 0.18 is the same as 18%. 0.30 is the same as 30%. Okay, check that work with my work, and then let's do vanilla. All right, so for vanilla, I got 0.16 right here at top, which is the same as 16%. I got 0.17, which is the same as 17%. And then I got 0.33, which is the same as 33%. Okay, the last row, I'm going to do it completely with you. So our total for, males? The total number of males surveyed was 45 out of 82. 45 divided by 82 is 0.548, so this rounds to 0.55, which is about 55% of the survey consisted of males, And then we have 37 females out of the 82 total, which comes out to about 0.45, which is about 45%. And we knew that 55% plus 45 is 100, so our math checks out. In fact, if you wanted to go through your table and add it up, 16% plus 17% should equal that. 12 plus 18 should equal that. 27 plus 9 should equal that. I think the only one that doesn't is this row, and that's because I rounded a little bit wrong on my second one, but that's okay. So just make sure you understand how to compute relative frequencies before we move on. You just divide by the total and then turn into a fraction or a percentage. Sorry about that. All right, make sure you have it down before we move on. All right, this slide for example 3 is just reviewing what we've done already together. So it's telling you, just kind of reiterating relative frequencies. So relative frequencies are proportions or fractions, okay? And we use our row or our column totals to calculate relative frequencies. So we can do our totals this way or our totals this way, okay? To find those relative frequencies, we call these row relative or column relative. So obviously row relative would be the row and column relative would be the column. Okay. Below is a two-way frequency table for you to reference to calculate the proportion of male students who prefer chocolate ice cream. So if we were going to male students who prefer chocolate ice cream, if we wanted the row relative, we would do 22 divided by 45 because that's our row relative. If we wanted the column relative, we do 22 divided by 30 because that's our column. Okay. We're going to go ahead and move to the next slide where we interpret this table a little bit more. All right, on this slide, we're going to be looking at our table up top to answer a few questions. It says, suppose you're interested in the proportion of male students who prefer chocolate ice cream, sorry. How is this different from the proportion of students who are male and prefer chocolate ice cream? What is the difference between those two questions? Because they are different and they're going to give you different answers. So maybe I would say find the proportion of male students who prefer chocolate ice cream. So let's look at our table, male students who prefer chocolate ice cream. Well, there are 22 of them. Okay. And what are we using as a total? Are we using the total of all of the students or the total of just the male students we surveyed? Think about that for a second, and we're going to think about what should we put down here as our total. Should it be 82 for all the students surveyed, or should it be 45 for just all of the male students surveyed? Here is your key right here. It says the proportion of male students. Okay, so we're just doing the proportion of male students. So there were a total of 45 male students. Okay. For this other one, we're finding the proportion of students who are male and prefer chocolate ice cream. So there were 22 male students who prefer chocolate ice cream, but we're finding the proportion of students. So it doesn't say of male students, it says of students. So this is out of the 82. Okay? So this is how these two are different. One of them is asking you for the proportion of male students. One of is asking for the portion of students. Okay? We have the same numerator for both of these, but our denominator is different because we're talking about a column relative frequency versus a row relative frequency. All right, number 19 says, use the table provided to calculate the following relative frequencies. What proportion of students who prefer vanilla ice cream are female? So we're looking for the proportion of students who prefer vanilla ice cream that are female. So there's a few things I want to write down here for our numerator and denominator. The first is our top number is going to be Female students who prefer vanilla ice cream. Female and vanilla. Okay? Our bottom is going to be the proportion of students who is going to be the total students who prefer vanilla ice cream. Okay? And this is how we're going to calculate this relative frequency. So female and vanilla. So we're looking at our female category up here and our vanilla category. How many females who liked vanilla are there? There are 14. Okay? And how many total students prefer vanilla? Well, there were a total of 27 students who liked vanilla. So this is the relative frequency that we're going to find. We're going to do 14 divided by 27. And when we do this out, we get a relative frequency of 0.52. If we want to turn that into a percent, you can. It's a little bit easier to interpret, 52%. All right, we're going to move into a little bit more interpretation on the next slide where you're going to practice this together in groups. All right, with your breakout groups, I'm going to send you to go answer these 3 questions. 20 says a student selected at random from the school. What would you predict the student's favorite ice cream to be? Explain why you chose this. 21 says, suppose the random student is a male. Now what would you predict his favorite flavor to be? And explain. And then number 22 says, suppose the randomly selected student is a female. What would you predict their favorite flavor to be? Okay, I'm going to send you to breakout rooms for about 2 minutes. I want you to come up with 3 answers here, and then we'll go over them together when you return. All right? All right, for this first one, if I was just saying somebody is randomly selected, I don't know their gender, then I'm just going to look at the total numbers down here for people who liked ice cream. Okay? Most people, doesn't really matter their gender, most people preferred chocolate. So I would say that if I was just randomly selecting a person from the school, I would say probably chocolate. And the reason, it's the most popular, no matter the gender. Okay. Next one, what if the student is a male? Well, then I'm just going to look at my male column right up here. So for the males, what's the most popular? Well, chocolate is still the most popular for the males. So I would say chocolate. It's the most popular flavor for males. And then the last one says, well, what if the student is a female? So I'm going to look at the female column. What's the most popular for females? Strawberry. So I would predict that it's going to be strawberry. Because it's the most popular for females. So that is how you use your frequency table to make a prediction based on your data. Obviously, there's not really a surefire way to predict someone's favorite flavor or frequency of something, but patterns are everywhere around us, and we can use tables and frequency tables and models to do that. And so this is just kind of showing you how. All right, let's move into the closure before we do our exit ticket. All right, to close out this lesson, univariate categorical data is one variable that's displayed in a frequency table. Bivariate is 2. Displayed in a two-way frequency table. We find our relative frequency by doing our frequency divided by the total. We can divide that number to find our decimal, and we can turn that decimal into a percentage pretty easily. A cell relative frequency is a frequency that is just in one box, right? So it's that fraction that's in that one box. A row relative frequency is the frequency that's in that whole row, right, at the end. And A column frequency is the one that is in the column. Okay, let's go ahead and look at what you're going to be doing for your exit ticket today. All right, for your exit ticket that's in Galileo, you're going to have to use a completed two-way frequency table to find relative frequencies and write them as percentages. You're going to need to interpret two relative frequencies in the context of the situations. You just have to tell me what they mean. What does that 13% mean in this situation? Okay. You're going to have to distinguish between categorical and numerical data. So you have to tell me the difference between those two. Distinguish between univariate and bivariate data. Tell me the difference between those two. And then you're going to need to use a completed frequency table to make a prediction. When you're done with that, please work on your reflection and any weekly work you may have.